Thank you, everybody, for tuning in to Coder Conversations. Today, we have staff software engineer at Warner, Srivathsava, Rangarajan. I hope I pronounced your name correctly.
Good enough. Most people just call me Shri to make that easier.
Nice to have you on tonight, Sri.
Pleasure. Thank you, guys.
It's definitely a pleasure to have you on. And yeah, you have a very elaborate background in software. You've been at quite a few different companies, and you've been at a high level for a long time. So, do you mind giving us a little bit of background about your software background?
Yeah, for sure. So I had a pretty, I want to say, unorthodox introduction to software. By training, I am an electronics engineer. So I did my bachelor's in electronics engineering in India. So, lots of like chips and microprocessor design and that kind of stuff. But I was always really into software and computers in general. And even when I was doing my bachelor's, the bits of my degree that were very exciting to me all had to do with stuff like operating systems and software. So it's kind of like a natural uh, tendency, proclivity, if you will, to kind of like go deeper and deeper into the software side. So I came to the
Sure.
US.
Yeah.
I came to the US 2012, went to Purdue, did my master's in computer engineering. Did my thesis dissertation was on distributed systems, specifically the Paxos consensus protocol. And then after that, I got directly into the industry. I worked in fintech for a good 6-7 years, and then I've done like a few, like about 2.5 years of logistics, and right now I work at Warner Music, which is entertainment.
Right. So how did you like the fintech?
Fintech, frankly, in my opinion, is like the most mature of the domains that I've worked in when it comes to software. So kind of it was a very interesting experience to go from fintech to logistics because it allowed me. That's so one of the reasons why I chose to leave my first company, although it was a very comfortable position for me to be in, is just to develop some bias. Like you need some perspective, and one point doesn't create perspective. You need to like see a few things in order to like look back. And I feel
And then like in hindsight, you can make sense of it.
exactly. So like going from like 7 years of fintech into logistics, one of the very first things that was like blindingly apparent to me was how much more mature the general industry is, right? And I want to attribute that a lot to do with like how we think about money. I mean, when was the last time like you guys have dealt with like hundreds of, or if not thousands of dollars of cash in hand, right? Like most transactions these days are digitized, right? Like when you think about your bank account balance, you don't go to the bank and like ask them to give it all to you and like count it out by hand, right? Like it's a number on a screen, right?
Yeah,
And
right. It's a number on the screen.
exactly, and like it's been a number, if not on a screen, on a book, on a piece of paper for decades now, right? Like double book accounting is quite old, and I think that sort of abstraction of thinking about the domain naturally in terms of these abstract concepts, like interest, principal, accounts receivable, accounts payable, right, is a thing that the industry has naturally been doing for so many decades that it becomes much more natural to translate that into software, right? Because if you're talking to product managers in that area, they naturally think in these abstractions. You don't have to go to them and say, hey, forget about the greenback, forget about those like piece of paper. Let's think about numbers, because they already do that, right? Like they come from backgrounds where, they come from backgrounds where this is natural. Take in contrast something like logistics, which is still a very like touch and feel industry, right? Like you're talking to like some of the movers and shakers in logistics, some of the like biggest CEOs out there, and they have brilliant ideas, but they still can't stop thinking about things in trucks and ships and planes. And that shift takes time, right? Like that paradigm shift to look at it and go, wait a second, this isn't a truckload. This is actually just abstract cargo, right? Like that sort of maturity is very present in a domain like fintech, and so
to see it in another light, so to speak.
Yeah, to go like one abstraction higher, if you will. I feel like fintech is already there.
Gotcha.
and that's kind of like why we're seeing so much innovation in fintech, right? Like just think about like the stuff that we've been doing in fintech. Even think about stuff like crypto, right? Like now, caveat, I'm not like really into that space, but like even if you just think about the idea of something like that, it's a direct result of the maturity, at least in my opinion, of like how far that space has come, right? Like where you're like just thinking higher order abstractions constantly. And so yeah, if anyone is really interested into like in that, hey, I want to like write software at the next level, and I don't want to be spending my days and nights trying to convince my product manager that like, we have to like look past the obvious, look past the reality. Fintech is an excellent place to do that. That's where some of the like harder problems to do with like scale and like, commerce, like think about Visa, think about like, the space is ripe for like optimization, because the ground layer has already been laid for like thinking about the formalized version of finance.
Yeah, I mean, to me, from what you're saying, it sounds very highly creative, very creative.
Yeah, and that's only possible because the common language for talking across the business and the tech functions has already been established.
Right. So, yeah, you're currently working at Warner Music Group, and it's a completely different from fintech. Obviously, you're coding in both places, but is the problem modeling and problem solving skills you have to utilize completely different?
That's a good question. I would say that like yes and no. I think at Warner, a lot more of the challenges lie in the area of like defining the problem, right? So you're talking about like problem modeling and problem solving. Uh, I would like to think that like as engineers become, as they grow in their careers, right, as their seniority progresses, a lot of the time I feel, at least in my career, has been spent in trying to nail down what problem is worth solving, right? Because there's a lot of opportunity, right? Like you could send an engineer to track down every little problem in the company, like every operations person, every accounting person, every artist management person has a small idea of like how they think, or maybe a large idea of how they think computers can help them. But really the challenge, and this is challenge across both product and engineering, is to try and sit down and look at all of that and go, hey, what is the common pattern here, right? Like what is the abstraction, if you will, and then how do we solve it? So to me, that is like one of the critical steps that senior engineers play, which is to collaborate with product managers, define the problem. And I think that is very different between fintech and Warner, or say my previous company, like a firm and Warner, where at a firm, the product managers had a much more authoritative view of like what problems were worth solving. And I think that goes back to what I was saying about the ground layer is well laid, right? Like they already understand the abstractions, so they come to you with very well defined problems. And so the role of a senior engineer kind of shifts in that, like you don't have to help that person define the problem, you just have to like really think about the technicalities of that problem. And I
Right,
think
that's pretty cool. That's pretty cool.
yeah, and I think at Warner, it's more focused on kind of like working closely with that person to help them even understand where tech can be making the difference, right? Like, so your product manager isn't your typical tech product manager in entertainment. It's more of like a product specialist, right? Who has like incredible knowledge of the domain, like the product's like expert, if you will, the subject matter expert. But you're sort of like helping them understand what is worth solving, where can technology make a difference. And so a lot more time goes into like that problem definition more than the like finessing of the technicalities of a defined problem.
Right. And now, do you have producers in these roles or not really?
When you say producers, do you mean music producers?
No, more like in the video game industry, there's producers.
Yeah. So yes, so I guess
So
like
is
in
it
that
like that at all or not really?
yes and no. I think that like we would have, so Warner is an interesting place. I can't speak about the entire entertainment industry because I just don't have enough experience. But at Warner, we've always had product managers, I want to say. And that's because technology has always sort of like played a role, even if not a role that is as emphatic as like some of the newer leadership wants it to play. So, we've been distributing music literally as physical CDs since the 90s and the 2000s, right? So product management has always been a thing that has to exist. I think like in terms of like where that becomes more of a production thing, like more project oriented. I don't think we don't have specific producers, right? Like we don't have like that as a dedicated role, and that's sort of like what the product manager, the senior engineering staff, both in terms of like the engineers, the ICs, and also the engineering managers all come together to play that role. There isn't really a dedicated role that we have. Now, of course, Warner Music does have producers, right?
Right.
But like that would be more in like the pure sort of like artist space, right? Like like when people are
More
making
like
music.
a music
Correct.
producer, you're saying.
Correct.
Yeah, right.
Exactly.
Okay.
Yeah, but not in the tech side. In the tech side, you're sort of like the engineering manager and the product manager and like your staff and senior staff are kind of like sharing those responsibilities on delivering the projects.
That makes sense. Yeah, I can see that.
Yeah.
So yeah, you spoke about problem solving and defining the problem. Like, what is your process for defining which problems are important to solve? And once you've determined that, how do you go about like formulating a plan to most efficiently solve those problems?
Yeah, no, that's a great question. I would say that the best way is to like get close to the people feeling the pain, right? And collecting data, collecting information. So for me personally, and this is just how like I've created my own process over the years, I form very close relationships with the people who have the most subject matter expertise, right? So in this case, I'm very lucky because there are like music is like an old industry. Warner Music is a very old company. And I'm very lucky in that a lot of these product managers that are at Warner have been with the company for sometimes decades, right? Like, the tenure on our team is sometimes mind-boggling, something that we don't normally see in your traditional Silicon Valley tech. Some of the product
Right.
manage, yeah, like we're talking like 15 years, 25 years, like a
That's
very like
not too common. Yeah,
yes,
that's not too
yeah,
common anymore.
not very
Oh,
common.
yeah.
Exactly. Yeah. So I mean, my day one was to like make the tightest relationships with those people, right? Like to really glom onto them so that they can sort of be my like everything, like my guide, my litmus test,
Your
my
mentor. Yeah.
mentor. Yeah, exactly,
Yeah.
right? Like so get really close to them, because at the end of the day, you know no matter how good your idea is, it has to make sense in the industry, right? And nobody knows industry like the
Sure.
people who've been in it, right? And so yeah, the problem definition, it's a combination of those two things, right? Like you go and talk to the people feeling the pain, and then you go and talk to the people who have been around for so long that they can tell you if this is something that's localized or something that's a pattern, right? And I think that's really your step zero, if you will, of like understanding, hey, is there a problem here? Is there like a generic problem here that's worth solving?
Right. So the industry has been shifting rapidly, and speaking of problem solving, like you just mentioned, we spoke a bit about boot camps prior to going live, and I know you mentioned that they kind of focus on syntax versus maybe problem solving. So do you feel like a lot of these boot camps are not really preparing new boot camp initiates for the industry, especially with all the changes going on?
Yeah, I that again, an excellent question, and I will be honest in that like I haven't seen a lot of people from bootcamp come through our like hiring processes in the past couple of years when I've been interviewing people. But I can talk back. I can kind of like reflect back on like when I did see that happen in the industry, and I have also tutored on the side for like I want to say like a year and a half on like various online platforms. And interestingly, a lot of the clients who would show up would be from boot camps, right? And so I've kind of like got like a front row seat to see the kind of assignments that they're being given from boot camps, and it has a lot to do with, I think, coloring by numbers, right? Like they're given a framework, like say for example like Django over Python or like Ruby on Rails, right? And they're told to implement a website, right? And the bootcamp is kind of like optimized as an industry to churn out people who have a portfolio that they can then go to take to interviews, right? So it's like, hey, make this website,
Sure.
do this thing, yeah,
Sure.
use a device gem, use this thing, make a login. And at this point, I feel like AI can just do that, right? Like it's really syntax driven. It's kind of like reading documentation, trying to understand which method to use, what arguments to pass, and then you're kind of like done. And I've not really seen in my experience trying to tutor some of these bootcamp grads or like students, them bringing me any problems that had to do with like open-ended problem solving. Like it wasn't like,
Right.
hey, yeah, like you got this ABC situation. How would you model this as an engineering problem, right?
No,
Like how
no, like leak code.
Yeah, no, definitely no lead code. Although I have like reasonably strong opinions, I would say even about something like lead code, because I feel like that ends up focusing, interestingly enough, like one of the big problems we're having with our interview process right now is that like lead code is just trivially solvable by AI, right?
Yeah,
Because
right, exactly,
yeah, you
exactly.
just give it like a, hey, find this all the triplets or quadruplets or two tuples that sum up to a certain number in an array, and it gives you like 17 different ways of doing it and gives you the time and space complexity to boot, right?
Right,
Because
or use this data structure, use this
yeah,
algorithm, or
it's
whatever.
really good. It even explains it to you, right? Like, so I feel like the bit that kind of gets lost in the mix of all of this is what was being referred to before this, which is how do you take a real life problem that humans are facing and find out, like I'll take an example. Hey, I'm sitting in my basement right now and it's pretty cold. Can computers solve that? Can they make it less cold? I mean, I know that sounds ridiculous, right? Like, but that's the sort of like bit that AI can't just do yet, right? Like AI can give you, like if I probably put this into like like a cloud or like a chat GPT prompt, it would probably be like, yeah, cool, we can like, let's talk about like a thermostat that can be connected to like an internet of things, and we can plug that into your like furnace and help keep the temperature. But it's not going to like think of like insane out of the box solutions like, hey, is somebody running like a Bitcoin farm next to you? Because if you put that into your basement, it'll keep it warm, and that also cools their Bitcoin setup. I know that sounds insane, but that's sort of the stuff that like you want engineers to think about, right? Like that's the creativity and problem solving in engineering that at least right now I'm not convinced that like AI can take over. That like really crazy out of the box, like take the zeitgeist, digest it, and like try to like marry completely disconnected things to see if you can solve a problem. It's that kind of stuff that I'm not convinced just yet that like AI can solve. I think it's very good in like very narrow niches because it's just so good at like digesting massive corpuses.
Yeah,
Uh,
and stuff like UI, UX, I
yeah,
think it's
yeah,
really well suited for that, and
exactly.
probably, AI is more than likely going to replace a lot of graphic design roles, or severely limit the dependence that we have on those type of roles.
Yeah, but although the UX part is very interesting, I feel like that is like what is cool, right? Like what is usable is a very human question, right? And so I think that like those kinds of roles might become, if anything, more interesting and more emphatic. I think the stuff that AI is going to get really good at is exactly the kind of like lead code problems, right? Like so I, I would say that like to the points that both of you have made, the role that like more senior engineering folk or all engineering folk are going to play, I think, in the future, it's kind of like on both sides of what like AI can do, right? Like the trivial one is make sure that what it spit out makes sense, because a lot of times it doesn't, right? So it's still getting good at that. And then on the left hand side, you have to like take that real world human problem and convert it into its lead code version, right? Like you got to go to the AI and say, hey, I want you to write me a function that takes this and gets me this. And so you're still playing kind of like puppet master over all of those. You're the orchestrator or over like all of those like atoms of functionality that it might implement for you, right? Like you're the one that's like digesting and splintering the space into little chunks that it can code up for you, and then you're kind of like putting it all together, right? And so that's why I was saying that like I think it's going to be more of a blend of like a product manager role combined with like a QA role, combined with like like the your classic engineering role, right? Like that that's how I see this space evolving.
Right. And what about like a software architect? How does that feed into or fit into this scenario?
Yeah, that's a really like I feel like uh, if of all the things that I'm concerned about, that's the bit that I'm most concerned about, because at one point, because one function is becoming so much easier, right? Which is to like implement the code bit is getting easier because like there's this tool that can do it very efficiently for you. I feel like the pressure will show up in a different place, which is stuff like reusability gets more interesting, right? Like a really good software architect will still be able to like define the kind of shareable paradigms, the general posture, the frameworks that we should be using. So to answer your question more concretely, I think a software architect would be doing exactly the same thing that I described before, just one abstraction level higher, right? So instead of like thinking about a concrete, yeah, like instead of like a concrete problem being translated into solutions, that person would be thinking about all concrete problems in that product space and then trying to like create common patterns. So it's the same thing, it's just like one level deeper, right? Like you're looking at like software pattern instead of product pattern.
Yeah, and it's got to really come down to creativity. How creative is the engineer? How far can they push the limits of what they're working with?
Exactly, yeah, of that. And I think it's going to come down to some discipline. This is a bit, like I said, I'm a little concerned about, which is in some sense, the fact that all this code takes us time to implement today gives us time to pause and reflect, right? Like I can't write stuff as fast as AI, and nor can most of the people on most engineering teams today. And so in the time that we are mechanically implementing something, space is created, like a time is created for us to think about whether what we're doing is worth doing, right? Like we're able to, because of the like work that we put into doing that thing, we're able to like take a few minutes, hours, days, weeks to reflect and ask the question, hey, is it worth doing? Like, is there something like, is Joe on the other team kind of like doing something similar, right? My fear is that like with AI replacing this to the point where it's like, write me a function, write me a function, write me this framework, write me this thing, whatever.
Yeah,
I feel like we're going to end up with this like hodgepodge of stuff that's all working, but it doesn't gel together, you know?
Yeah, no, I get that. I get that.
So like I kind of see AI as just like an even higher level language. We started with
Yeah,
machine code, then assembly. Those took really long to do things. Then we moved on to like C, C++, and now we're at like JavaScript and Python. And I think AI is maybe a level above that, where we're essentially programming in human language, and you still have to know how to speak to the AI to produce the correct result and an efficient result.
absolutely. Yeah, without a doubt. And well, yes. And I think like I think you talked about two different things, correctness and efficiency. Um, yeah. And like there's always going to be cases where you go deeper, right? Like, so you're talking about Python, you're talking about efficiency, little oxymoronish, right? Like there's still places in this world that write assembly. There are still places in this world that write COBOL or C, right? But not everyone needs to write C, right? And so some people write Python, and some people write Ruby, and some people write TypeScript, right? So efficiency is one thing. Correctness is the more interesting thing. I wonder when we're going to get to a world where we will have the equivalent of compilers for AI generated stuff, right? Like where we can like audit, because it's pretty easy for us to like forget how far we have come in terms of like this development. I mean, when was the last time, I'm not talking about like the really cutting edge people who are like finding bugs in, memory leaks in some Java standard libraries implementation of like a circular queue or a heap or something. But most people in this world do not know the package in which that lives, right? And yet we use it very confidently, and we use it with this like disclaimer that like, look, man, most of us can't do better than that. So that is the standard now, right? That is not true with AI, right? Like we still have to check what it says, because a lot of times it's hallucinating. It doesn't know what it's talking about.
Right, it
It contradicts
hallucinates.
us.
It gets stuff that's not really lined up with what you're looking for.
Yeah. So like I think of like, it's just interesting. I'm sure you guys seem pretty savvy in the space. Like, Google put out this like red alert a couple of years ago when like ChatGPT, like the 4.0 took the 3.5 took off, and they were like, oh my god, we're threatened that this is going to start replacing what Google search is doing, right? And obviously Google search these days also has a generative element baked into it, but that's sort of how I think of AI right now, right? Like, or at least the way I use AI on a day-to-day basis, like, your ChatGPT, your large language models, right? Which is a good search engine, right? Like I am still responsible for vetting what it says. And so I am the intelligence, right? What it is a very effective assistant where I don't, it's like it's Stack Overflow combined with Google on steroids, right? Like as it pertains to software.
Yeah, no,
Yeah.
that's a great way to look at it. Great way to look at it.
Yeah. So yeah, but really, I mean, to your point, sir, about will it become the next abstraction? Will it become the next programming language? It will once we have compilers for it, right? Like it will once I no longer have to peek under the hood. It will once like 99% of the engineering force and population just takes what it says for granted, right? That is
Right.
so far away from being true today. So, but I think it's the advent of something like that for sure.
Like, do you ever fear, like, okay, as we become more reliant on AI and the generated output, and people start losing the knowledge of the lower level, that
Yeah.
it's producing something that kind of looks like it works, and
Yeah.
you start stringing that together, but it doesn't. It's going to fail in a critical way because we're not necessarily fully understanding everything
Yeah.
that it's spitting out.
It's again an excellent question, and it's something that it's interesting because I was talking to one of my ex-colleagues about, and I respect this person a lot, and I was like, hey, I think of myself as somebody who is really interested in the like nitty, like the deep down details, right? Like I want to know exactly what an object in Ruby is, right? Like how is it realized in C? How exactly does it work? Like where are the race conditions? Most people don't do that, right? And so I have a penchant for diving deep, right? And so I was trying to like make the case to this person that like I am afraid of exactly the thing that you're alluding to, which is like that even less people now are going to be like it's one level more of abstraction. And like your proverbial person who was copy pasting from Stack Overflow now no longer has to like even do that bit. They can just ask AI and copy pasta from there. And so more and more burden is going to fall on the reviewers. And like, do we really know what it's saying is good? Can this be used as attack vectors, right? Like to do like whatever security vulnerabilities, take advantage injections, etc. And this person, he's really into cars, right? Like he to the point where like he part-time rents a garage and works on his own like GTI. And so he was telling me, hey, you have a car, right? How much do you know about your car, right? Like, do you know how to change even like the oil in your car? And the answer is I don't. And
Yeah,
he was
no,
like,
same here.
yeah,
Same
yeah.
here.
I mean, I use my car every day, right? Like and I I've been into cars. I like cars in general. I could probably point out a few of the things if you open the hood, but I don't change my oil every day, and I could not tell you. Like, if you gave me a gun to my head and like 5 minutes on like, hey, change the timing belt, I couldn't even tell you where the timing belt on my car is,
Yeah,
right? And
right.
so like his point here was that like the world sort of like invents an abstraction, and he was kind of like alluding to like think about our fathers and grandfathers and grandmothers, right? in World War II, even Queen Elizabeth uh, knew how to service jeeps in the war, right? And now I can't tell you how to change the oil in my car, right? And he is like, yeah, look, new abstractions are birthed, and they take some time to get good, and eventually you just come to rely on them. Does that mean that they never break? They do, and mechanics have a place in this world. And so I think we will see the birth of software, the current software engineer becoming a software mechanic, right? To kind of like read all the code that this AI thing has written and go, all right, let's take a look at what's really happening here, right? And most people will not have to do that. And, we will charge by the hour, and labor will be expensive, and, capitalism will continue to turn the wheels of the world. So yes and no, I think.
Yeah, I think that's for certain. Yeah.
Yeah, I do feel like it's going to create a niche for people who really understand what's going on at a low
Yeah.
level, like you said, to make a lot of money, because they're essentially going to be able to hold companies hostage, almost like a mechanic.
Yeah, at least in the short term, right? Like I feel like transitions, change is always a great time to make money. And so in the short term, absolutely. And I think, once you get like the Subaru and the Hondas and the Toyotas of AI, yeah, probably less money, right? But still there'll be a space, right? Like things will still break, and somebody will have to take a look at it, and people will just get really good at those AIs, right? Like, so my feeling is that like we'll go from like your generic software engineer to like somebody who is just really good at understanding how Claude churns out code, right? Or like how Anthropic churns out code, or like how ChatGPT churns out code. So you can kind of like get specialists, and then you'll kind of like see. I'm just taking the car analogy because of my conversations with this friend of mine. But yeah, I think that will happen. And so in the short term, it's going to be a little bit of the wild wild west. And yes, like people who are good at what they do, like people who understand the abstractions, will make a lot of money. But in the long term, as these products get good and reliable, then we will see specialization, is my feeling at least.
Yeah, I was going to just say that specialization, I think that's going to be extremely key going forward.
Yeah, for sure. And, it's just natural. We already see that, right? Like even just think about, I mean, you were alluding to C, C++, and then the evolution into like JavaScript and Python. I feel like very senior developers, so I'll take my own example. I have worked extensively in my career with Go, Ruby, and Python, right? Does that mean that if you put some TypeScript or Java or C or C++ in front of me, I'm completely lost? No, right? I think I can sort of like piece together enough to understand and come to some conclusions about what is happening. But at the same time, I don't think that I am going to be as good as somebody who has just been writing Java for 20 years, right? So I think specialization is just natural. I think this sort of myth that we feed ourselves that like, software engineering doesn't really care about languages is only true at like the very low levels. And this is again what AI is going to do very well, right? But when it comes to like true deep specialization, it absolutely matters, because at one point it becomes less of a science and more of an art form, and that's really where like experience starts to shine through. And I think yes, specialization is going to matter.
And then that's really where creativity shows itself. When you say,
yeah, absolutely. Yeah, you could. That's really where you'll be able to see stuff. We talk about design all the time. We talk about modeling all the time, right? Like how you model the solution. I think one of you had asked the question to like, how do you first model a problem, and then how do you attack it from like solving for it? Yeah, I think that's really where the creativity and the design aspects start to show up, right? Like how you represent a formalized problem in Haskell, for example, versus how you would do it in an object-oriented fashion with, say, something like C++, right? Or even Ruby, are very, very different, right? Like this exact same solution represented in Lisp is going to look very different from how it's represented in Ruby, or say C++, right? And so I think that's
and also it makes me think of things like LeetCode, where okay, you answer the question in Java, and the solution in Java takes 25 lines.
Yeah.
Now the same solution in JavaScript takes like 2 lines.
Yep. Yeah, the terseness, right? Like I hate interviewing in languages that aren't scripting languages, mostly because of exactly what you said. Like most, it's kind of interesting because I think I see a question in chat about stuff like high frequency trading, and I've interviewed at companies like Citadel, where they give you some of these like lead code style questions where they will care about performance, right? But most people are giving you like the solve tic-tac-toe or like do the string reversal or whatever at like junior levels, and there writing that in Java, like it's like I want to say like 25 characters in Ruby, right? It's like a dot reverse or something. So yes, absolutely. There is flair. There is like creativity. There's style. Like with enough experience, especially in a team working with the same crew for some time, you very much can start picking up on different styles of people coding. Like if you put my team's code bases in front of me, I can tell you which code was written by whom because their natural style starts to show through. Do they prefer inlining? Do they prefer like what is their indentation? Like what kind of like code shapes do you start seeing show up? How do they name things? How do they modularize things? Right? Like those sorts of things are very much
Right.
an art form. Yeah.
Yeah, that's nuts. That's definitely an interesting point.
So yeah, I think we have a couple of questions from the audience. I think you've answered one, which is what are your views on pursuing HFT? And the other one is will working at Fang as an SDE give you the best experience as an engineer? Does it still hold value?
Yeah, I guess I'll take those in order. The HFT thing, personally, I've always been very fascinated with high frequency trading. What are my views on that? I think that high frequency trading is sort of a world unto itself, right? Like we're talking about people who spend billions of dollars on establishing microwave antennas so that they can, have their FPGAs relay trades to the board like 2 milliseconds faster so that they can make $10 million on the differential, right? I think it's a really, really, really cool space, but I think it is at the same time the nichest of spaces, right? Like a lot of these, like we're talking about code that is being flashed onto FPGAs directly. 99% of, again, I'm talking about like mass generalizations here. Most engineers, like software engineers, don't know what an FPGA is, right? It's a field programmable gate array. We're talking about like embedded programming directly onto the network cards because interrupting up through the OS kernel is just going to be too slow. We're talking like milliseconds being too slow, right? That is a very, very cool space to work in. But at the same time, it's also like you're now pursuing a career as a high frequency trading engineer, not as a software. You're like bread and butter industry software engineer, if you will, right? So you should do it because I think it's excellent experience. If I could go back as a graduating engineer, it would be the best time because the grind is hard, right? Like it's a very flat sort of it's typically these companies tend to be very results oriented, flat hierarchy. You can make a lot of money. You do have to like work incredible hours. So graduating into the space is going to be very rewarding and very interesting. But I would at the same time also not, I would say that like maybe not like you graduate from that space and you come back into the industry, like general industry, work in the kind of companies that I've been working at, and you kind of have to relearn a lot of things because like what you are taught to value in a high frequency trading space is going to be very different from what other parts of the industry that don't care about nanoseconds and milliseconds might care about, right? So I guess that those would be my thoughts on the HFT question. And I think the FANG question, will working at FANG still give you the best experience as an engineer? I think it's definitely a valuable experience. Does it hold value? Absolutely, right? I think that it's a great, like some of the kind of patterns that you see in the industry that have become sort of standard, right? Like I'll take microservices as the classic example. They make so much sense in massive company settings, right? Because most of these software patterns, architecture patterns that you come across in the world, they're really reflections of organizational patterns, right? Like the Conway's law is very real. And so a lot of these things that we are seeing, microservices, event-based architecture, uh, service-oriented architecture, like a decade ago, all sort of like stem from how do I organize 10,000 engineers working with each other at the same time, right? And I think nobody is better positioned to give you a front row seat to that than Fang is. Will it be the only experience that is relevant? I don't think so, right? My experience working with a lot of people who graduate from Fang is that they end up placing a lot of emphasis on things that they are taught rightfully to place emphasis on that might not make sense in the other parts of the industry. So as a couple of examples, stuff like performance, right? Like, one of my favorite beating bats is Kafka. I love Kafka. It's an excellent piece of technology. The whole stream duality thing with like stream table duality thing is very cool. But at the same time, hey, look at this thing that can process like 1 billion events a second. Okay, like how many of you work in companies that process 1 billion events a second? Right? You don't. It's highly unlikely that you are, right? Like the kind of stuff that Google has to do, the kind of stuff that Apple or like Amazon has to do, most people don't, right? So it's my gripe, if anything, with like the Fangosphere, if you will, is that it ends up sending the rest of the industry into a head fake, right? Like most people want to copy what they're doing in the hope that they are going to become the next Fang member because of using Kafka, when in reality, they could be doing that just fine with SQS or sometimes even just a simple database, right? So Fang will give you the opportunity to really need Kafka because they have the scale to really have maybe 1 billion events a second, right? And you should experience that. And so that certainly still holds value. But at the same time, that doesn't mean it's the only value and it's the only kind of like perspective on like what software engineering, all the different facets of software engineering that you should experience in the other domains and other companies in the industry.
Right, and you mentioned scale.
Yep. And like scale's an interesting thing, and Fang has it, and that's a good reason why you should go work at Fang, right? And that doesn't mean other people don't have it, but that is certainly like something that Fang is really well positioned to give you experience with.
So yeah, to kind of get back to the boot camp question, I think we're past the point where boot camps, I don't believe 6 months is enough to really teach the skills to come into software. So if you were to design your own mini curriculum to prepare someone who wants to come into software, what would you emphasize? Like, what would that look like to prepare them to get an internship or be ready to solve the problems of the future in the software industry?
Yeah, I think that data structures and algorithms is an excellent class, right? Like everyone should take that class, not so that you can answer a quiz on what is the lower bound on time complexity of inverting a red black tree or something, right? Like that. Highly unlikely that you're going to be doing that, and if you are, then you are a very niche crew that probably doesn't need my advice. But for most people, I still think that data structures and algorithms are very, very relevant and very, very important. Not again from the perspective of like O of one lookup in hash and like traversing a linked list is linear time, but more of what do they model, right? Like, so I think back to my graduate course on data structures and algorithms, which was called Computation Methods and Complexity at Purdue. And Professor Given, who was my professor, I actually audited this course and took this course because I loved it so much. He was very fond of giving examples for each data structure as to like how it might be relevant in the real world, right? And and the one that kind of like when I learned about it, I was like, oh my god, duh, so brilliant, so obvious, is priority heaps, right? Like heaps as a data structure to model discrete event simulation in the world, right? Like that sentence needs to like make sense to you deep down somewhere, right? Like where you have to understand the data structure well enough to go, oh yes, I understand why this data structure, a heap, is so good at modeling discrete events that require priority in the real world. So if I had to design a curriculum to coach people, that's what I would do, which is teach them data structures and algorithms in such a way that they're able to intuit what that data structure, the essence of what that data structure or that algorithm abstracts as it relates to real world problems that we come across. And I think that is possible.
I know that a lot of companies, they kind of follow the FANG model of, okay, let's, quiz this guy on leak code style problems, easy, medium. What would you say, what's the best way to prepare for interviews where they are using leak code?
I very, very pertinent question, because I'm actively in the process of rethinking how we interview at Warner Music, because I really dislike lead code style interviews with a passion, because I don't think they actually test the kind of stuff that we are looking for most of the time in the industry. It really feels like sort of one of those, like, how do you feel that day, and do the click, do all the things click into place. And it also gets much more difficult to interview more senior candidates, right? If you're doing a lead code style interview, because a lot more senior candidates don't spend 95% of the day just thinking about algorithms and writing code. In fact, most people don't do that at work. The newcomers, the fresh engineers, sort of have an advantage in that they just took those courses. So to answer your question, I would say specifically to solve lead code style problems, unfortunately, just do a lot of lead code style problems, right? Like, there are books out there, your proverbial cracking the coding interview or whatever. Yeah, just go through those. Like, you got to do the grind. It's almost like, unfortunately, you want to play the game. That is the game, right? I hate the game. Frankly.
It's a grind. Yeah, like you said, it's a grind. You just have to push through it.
Yeah. That being said, I will also say that I dislike it. And I think really good companies find a way to model their problems in such a way that they can, it's hard, right? Like, having really good interview questions that aren't lead code, but can still test your abilities to model and solve problems as an engineer is a very, very, very difficult problem, right? So lead code is sort of like the cheapest way to do it. And I think you kind of brought up the point, sir, about like FANG style companies being able to do that. I again want to point out that, like, FANG can afford to do that, in that they can afford the false negatives, right? There are so many, there are so many engineers knocking down their doors that they can afford to miss on those 3 or 4 candidates that would have been excellent hires, right? Because they have 400 more to interview after them. Smaller companies can't afford.
Yeah, it's interesting.
Right?
It's an interesting situation.
Yeah, so I would say that, like, I don't know if you guys have seen those ads about, like, give traditional hiring practices a break. Don't look at the resume. Some of the best engineers I've ever worked with, they didn't ever go to. So a couple of them didn't even go to college, right? They were self-taught programmers. They were just nerds that got into Lisp or like Fortran, right? And just took off from there. So I don't think lead code makes great engineers. It might be a fun puzzle game to play, but yeah, unfortunately, if you want to do that, if you want to, if you're interviewing with a company that still does lead code style problems, all I can say is, take every single advantage you can get, right? Like, go look through Glassdoor and see what sort of questions they ask. Go look through, like the different forums, prepare, do the top 30 lead code problems, whatever. Because unfortunately, if they want to, you're playing the interview game at that point, right? You're not playing the engineering game.
Yeah.
And if that's how they want to interview you, then just prepare to interview. Unfortunately, is all I.
Yeah, I mean, so like for me, when I was working in tech, I did have the opportunity to interview at Amazon, and it was very much, a lead code style interview. They gave me 2 easy in quotes. They're really not that easy. They gave me 2 lead code problems to solve, and I struggled with both of them. I wasn't able to complete either of them, and kind of at the end, I'm just kind of like shrugging, with the guy like, hey, thanks for having me, but I don't think we're going to move forward from here.
Yeah, exactly. I totally understand how you feel, because that was my experience interviewing with some of these companies as well. It was, if I got the offer, it's because I guess I was just clicking that day, and at the same time I've gotten rejected from some places where I was like, I I just, sorry, I couldn't invert a red black tree that day. I don't know what to tell you.
Yeah, but I think the problem with leak code too, like you mentioned, is just a game,
Yeah,
and you're not, people have to spend so much time trying to play the game that that's less time for them to develop relevant software skills. Like maybe they're not really learning SQL as deeply as they need to,
yeah,
or learning this or that framework because they're playing the leak code
yep,
game, and you're getting engineers who are good at lead code, but they're not
exactly.
necessarily good software
Exactly.
engineers.
No, absolutely. You nailed it. In fact, like I've seen a lot of people just take like a week off or two and just, you know, lead code, like full-time job, 8 hours a day for like 2 weeks before they start interviewing. Because they're just like, yeah, I forgot. I have forgotten, right? Like I don't. I interviewed recently, and they had like a lead code problem for me at Warner Music, and I think I just got a little lucky, to be honest, right? Like I was like, it just clicked that it's a puzzle, right? And turns out
Your
that day I was
brain
able to
was
solve.
working. Your brain
Yeah,
was
that's it.
working that day. It just happened to
Well,
be.
yeah, exactly. Working in that puzzle mode that day, the way they wanted
Yeah,
it.
puzzle mode. Yeah,
Yeah.
exactly.
But since then,
Yeah, we
yeah,
gotta.
sorry, I was going to say since then, that just because I got hired, and now I have I'm inside, and like I don't necessarily think that like I should shut the gate behind me, right? Like, so one of the first things I did when I got in was let them know uh, how bad this interview process was, right? And to their credit, they turned around and said, cool, do you want to make it better? And I said, yeah. And so that's sort of like how I got to the place where I am, like kind of like rethinking. And again, to their credit, they've been very, very, like, Warner Music in general has been like very open to like, hey, yeah, no, we totally understand, and we just haven't had the luxury of investing in this. But if you're passionate about this and want to make a difference, they've been very receptive to like the different ideas, and we are actively working on hopefully changing that process up.
Yeah, no, it sounds like Warner Music is really understanding of the issues.
Yeah, I hope so.
So yeah, we got a question from the audience: how to grow to a senior software engineer from a mid-level engineer.
Yeah, I mean, this is a pretty you're going to get the sort of almost like a canned response from me, which is perseverance, right? I would say like one of the biggest kind of I'd give you like two pieces of things to focus on: consistency and a multiplicative effect, right? Or like a multiplier effect. Consistency is very important. Like, you might be really, really good, but in order to grow to the next level, your superior, your manager, your supervisor, whoever it may be, needs to believe that you're consistently that good, right? So, in other words, it's not that like on Tuesdays, sometimes maybe Fridays of every other alternate month so far, so and so is pretty good and might be able to solve a hard problem. They need to be able to like show up to you with like any hard problem, right? Or a hard problem that befits your seniority, and then know that you're going to kill it, right? Consistently. So consistently being good, consistently meeting and exceeding expectations is very important. Not that I did one project really well. I did the first and the second and the third and the fourth and the fifth, right? To the point where you can be dependably good, right? So that's very important.
So they want to see the longevity,
They
is
want
what
to
you're getting
see,
at.
correct. They want to see the longevity, and really like
Yeah.
think about the promotion, right? From like mid-level to senior. In order to entrust you with that responsibility, they need to understand that like you can consistently produce results at that level, right? So that would be the first piece of feedback, which is consistency. Um, and then the second one, the multiplicative effect. That one's pretty self-explanatory. I had to like learn this the hard way. No single engineer the whole myth about the 10x engineer, the 100x engineer, whatever it is, that is, it's sort of like, in my opinion, misplaced or misconstrued, because a 100x engineer is not someone who's typing 100 times faster than someone else, right? It is someone who knows how to characterize and attack 100 times the number of problems that somebody else can, and that is impossible without a team, right? Without a set of colleagues that you can inspire and employ into action to go and do the thing that you would otherwise have to do over 100 days in one day, right? In order to do that, it's actually more, it's reasonably difficult, because this is really where the human element starts to show up. You have to trust these people, you have to build relationships with these people, right? And you have to be able to kind of climb up and down the abstraction stack pretty quickly. What do I mean by that? You have to be so good at doing the mid-level engineering stuff that it should take you 10 times less time than that person to sink back into the problem context of something that you have never seen before and understand it, wrap your head around it, and unblock them when they are blocked, right? And
wow, okay, that makes
and
sense.
you also have to do this, and this is the challenge. You have to do this in parallel across dozens of engineers, right? So my days, frankly, are spent going up and down the stack with all the different engineers on my different teams, right? Going, oh yeah, I remember that we had this problem where you wanted to do this thing. Remind me quickly about what that is again. Oh yeah, got it. And what are you doing here again? Okay, cool. Oh, I see what your thing is. You should really look at this, and you're gone, right? Because if you don't solve that in, like, 15 minutes or 30 minutes, you don't have enough time in the day to get to like all the other 20 people that need your input, right? So you have to, it's not that you lose mastery, it's that you have to achieve a level of mastery that is so good that you're able, and you have to do this at different levels, right? I am helping the SE once on my team, and at the same time, I'm having conversations with the senior engineers on my team and some of the staff engineers, right? So you're kind of like going all over the place, and you have to like tailor everything, right? Like how quickly you learn, how much you have to distill the information, your communication style, right? And all this without pissing off anyone on the other side and inspiring them.
Yeah, no, that's a great answer. That's a really good
Right.
answer.
So it's kind of like, I would liken it to, how you become a really experienced driver, right? Like to the point where it's not that you aren't paying attention, it's that it becomes instinct, right? Like you don't, like, if you have to brake only after you have seen the car swerve directly in front of you, it might be too late, right? You almost have to like have this sixth sense, if you will, right? And I think that, right, like you have to start developing that, and that only happens because you've been driving for 25 years. It's a natural evolution of like boredom almost, right, where you're like, you start playing this like one level higher meta game.
So yeah, he also asks, sometimes the senior engineers are unreachable and they don't have insights into what I'm working on. How do I make it visible to them?
So I, it's interesting. I wrote a couple of promotion recommendations for people on my team. I assure you that if you are consistently producing results, they are taking note, right? You have to get to the point where you are the first person that they're reaching for. When, okay, I'll take a direct example from stuff that I'm working on, right? Like right now, I'm not going to go into the specifics of the problem, but I noticed a problem. I know what the solution is, right? I have written out the solution in like 5 steps. I've drawn out a simple diagram. Now, the next question is, who do I hand this off to? Because I don't have the time to do this, right? Like, because if I did this, it would take like the next week of my time. And that means for a week, 20 other people are not getting my input, right? So it becomes that question of like, hey, I already know what the solution is. I know it's going to work, right? I've already thought it through. I just need somebody to convert this very, very faithfully with high fidelity into code. What does that mean? You're going to hit a couple of, curves along the road, right? It's going to be, my solution is going to say something like, yeah, and then make sure that like you add this like new column to this table. Obviously, we're going to have to backfill all the data, make it not nullable. And then once you're done with all of that, we will be able to like use this dimension for prioritizing our order processing, right? I left about 75 things in there unsaid, right? For example, hey, this table has 200 million rows in it. When you add a column into it and make something nullable, you're going to lock the table. Don't do that, right? If I hand this off to you and you come back and you tell me 2 weeks later that it's done and there was no production downtime, I'm going to take note. Because the next time something like this comes around, I'm going to say, hey, you know who killed it last time? This guy. I'm going to give this guy another one, right? So it's almost like a quarterback. Sorry, I'm going to use NFL. I'm a football fan. It's almost like a quarterback, wide receiver, mind meld synergy thing, right? Like if you keep catching the ball, right? Think Gronk and Brady, right? If I know that I can trust you, right? Of course, I'm going to keep giving it to you because you have not let me down so far. And at the same time, that now is building your portfolio to make the case to become this person because it's giving you experience into doing this repeatedly. So I think the visibility will become obvious as long as you're consistently producing results on projects that have these sort of like high execution requirements. Be detail oriented. Make sure that you don't, like, oops, didn't realize it would lock, right? Like, oops, didn't realize that we had to make this not nullable, right? Like,
Yeah, yeah.
think it through, right? Like, and do a killer job. Like if you're given a job to just, clean up the code base to get rid of like all of the usages of a certain style. Like, I'll take the example from Ruby. Allow any instance of. It's a terrible pattern that nobody should be using when testing outside of some really niche cases, right? And I come to you and I'm like, God, I hate this, like allow any instance of, right? And you go through the code base, read every test, figure out how to get rid of it, and you come back and like, it's done, Sri. There's no more allow any instance of. And I also added a linter rule to make sure that nobody ever writes it in the future. I'm going to be like, amazing, amazing. You've done the legwork, right? And I can depend on you to kind of like make sure all the I's are dotted and the T's are crossed in the future. And I think
Right.
that is self-evident.
Right. No, that's pretty clear.
Hey man, yeah, we're at the top of the hour, and
Yeah.
yeah, we definitely appreciate you for coming on. And we'll have to have you back. But before we close this out, did you want to leave our audience with any closing thoughts?
Hey, no, first of all, thank you guys so much for having me on here. It's been a pleasure, some really interesting conversation. And as for the audience, I think, kind of one of the patterns that I'm seeing is like a lot of questions about like value, fresh engineers, like career trajectory of being a software engineer. One thing that I would say is that like, of course, all of these things are very important, right? Like career is important. You make more money, you have more responsibility, you have a lot of respect. It's understandable, but don't forget why you get into this profession, right? I think that's like, if you want to make money, there are way more appropriate professions for you to go and make money in, because you're all smart enough to be in software engineering. You're smart enough to go and make money a million other ways, right? You don't need to be in software engineering. If you are in software engineering to make money, please reconsider the profession. There are better alternatives. But if you're in software engineering, kind of like why I'm in software engineering, which is you're just a nerd and seeing a bit come out the other end of a pipe still excites you, don't forget that, right? Like if you get
Yeah.
the further higher up you climb, the less opportunity you have to see that, right? Because you don't get to see the bits very often, right? Like you start dealing in features, and then you start dealing in systems, and then you start dealing in organizations, right? And you get farther and farther away from the thing that should really excite you to be in this field, which is, it's a sort of like almost like a world building. That's sort of what you're doing when you're writing software, when you're building systems, right? Like you're laying down the rules for a world that work according to you, right? You're kind of playing God in this world, right? And if that's what got you into this, enjoy it while you can, because it is true that as coding is a luxury. Solving problems at like the very lowest level is a luxury. It doesn't feel that way, when you're making like half or a third of what your senior engineer or your staff engineer is making. But sometimes I just wish that's all I did, right? Sometimes I wish all I had was a month in front of me and 10 feature tickets, and that's all I had to do. Well-defined problems, and I could just sit and pontificate on whether I should be using a heap or a circular queue or a hash map, because such well-defined problems, that's a luxury. Because the higher up you go, the less of that you're going to have. So enjoy it. Don't forget why you got into software engineering. And I hope I'll see you guys around the block.
That's great
Absolutely.
advice.
Yep.
Yeah, it was awesome having you on, man. And I would definitely bring you back. And we also like to thank everybody for tuning in. We'll catch y'all next time. Peace.
All right.